Hello everyone, my name is Ganesh Mireskar. I am an assistant professor in Civil Engineering Department of Sri Siddheshwar Women's College of Engineering, Solapur. So today we are going to discuss about the degree of kinematic indeterminacy. So in today's lecture, we are going to discuss about the topic, the basic of this concept and the previous year solved questions. Okay, let's start. So first of all, we will discuss about some important terms. First is the pin jointed frames. So these are the members which are connected by just pin. So members carry only axial forces, and so angle between members, sorry, here changes due to applied load. Okay, so in rigid joints, member carry axial forces, shear force, bending moment and twisting moment. So angle between members remains the same. So here there is a mistake, so angle between members changes. So next, so plane frames are the members in where all members and loads are in single plane, right? In space frame, so members and loads can be in different planes. Okay, so let's have an example, that is the rigid joint of plane frame. So here we are suppose there are three number of degree of freedom, that is delta x, delta y and rotation at each joint. So likewise dki will be 12 for rigid joint plane frame. And if we make the axial deformation in y direction, there will be 2 degree of freedoms at these joints, and here there will be only rotation will be there, as the delta x at this point and at this point have the same value. Okay, that's why we are counting it as a 1. So total dki will be 6. So here for fixed support there will not be any degree of freedom, that's why dki is 0. At pin support, one rotation will be there. At roller support, rotation and delta x will be there. Okay, so the deflection in x direction. So at free end there will be theta, delta x and delta y. So rotation, deflection in x direction and y direction. If vertical guided support is there, then deflection in y direction. If horizontal guided support is there, so delta x will be the degree of freedom. At internal hinge, if three number of members are there, so there will be 3 rotations and 2 deflection, one is in x direction and one is in y direction. Consider an example of simply supported beam. Prepare a table having joint delta x, delta y, theta, joint a. Okay, there will not be any deflection in this direction, neither there will be a deflection in y direction, but there is a rotation after deflection, so one rotation will be there. At b, if we neglect the horizontal displacement, deflection, neglecting axial deformation, okay, there will not be any delta x due to neglection, we are neglecting it. There will not be any delta y. Okay, there will not be any delta y displacement in vertical direction, but there will be a rotation at the support, so dki will be 2. Similarly here at point a, as it is a fixed support, delta x is equal to 0, delta y equal to 0, rotation is equal to 0. If we are neglecting the x displacement, okay, then delta y will be there and rotation will be there, so dki is 2. Here at internal hinge, 2 rotations, okay, at ba and bc, and here deflection in this direction, but we are neglecting in x direction, so we neglect it. So 3 number of degree of freedom will be there. At c, if we neglect x direction, deflection in x direction, okay, so there will not be any delta y. Delta x is also 0 as we are neglecting it, but there is a rotation at the support here. Okay, similarly for this point d, so there will be a delta y and rotation. And again at free support, free end, we know that there is a horizontal displacement, but we are neglecting in this case, so total dki is 6. Here again rotation here, rotation here, and here there will not be any you can say degree of freedom. So if we neglect the horizontal displacements, so dki will be 2, that is rotation at this point a and rotation at point b. Again directly allot the rotations without drawing any deflected shape, that is the shortcut method. At point a, one rotation, roller one rotation, neglect the axial displacement in x direction, dki is 2. Here at hinge support apply rotation, dki is 1. At free end neglect the axial deformation, deformation in x direction, dki is here degree of freedom 2. Here neglecting axial deformation, the deformation in x direction, here neglecting deformation in x direction. So 1 2 3 and 4, dki is 4. Again dki, here in totality 4 degree of freedoms will be there, 2 rotations and 2 displacements. Here there will be 1 rotation, here 2 degree of freedom, 1 rotation, 1 translation in x direction, here 3. So if we neglect the axial deformation in x direction, dki is 7, and if we consider it, dki is 10. Some questions are there from previously asked previous year questions that from Gate, MPSC, IES and SSC. So here 2 degree of freedom, that is x direction, displacement in x direction, rotation here for common for all, delta x common for all. Okay, so if we are counting it as a 1 degree of freedom over here, so 2 degree of freedom. Again similarly, delta x for this joint, delta x for this joint, and delta x at this joint, these are same, so we count it at once over here. So degree of freedom is 2, at roller degree of freedom 2, hinge roller degree of freedom 2. Here actually it is 2, but we are counting it over here once only. So here only for rotation, degree of freedom only rotation, degree of freedom only rotation. So total count is 2 4 6 8 9 10 11 12 13, 13 is the dki. Next, if we consider all the deformation degree of freedom, so at each joint there will be 3 number of degree of freedoms. So likewise 3 7 3 3 9 3 14 12 13 14 15 18 3 17 21 22 23 24, 24 will be the degree of freedom, that is dki. Okay, so one MPSC question is there. So delta x is common, so we are counting it over here once only. So delta x is counted over here only. Here only rotation, rotation, delta x and rotation. Here for these two common delta x, that's why we are here only 1 rotation, here delta x and rotation. Here again same concept, 1 rotation, delta x and rotation, delta x is common for b and e. So total 2 4 6 7 8 9 10, so 10 dki. So degree of static indeterminacy, that is having some different concepts, so time being we are just going to calculate the kinematic indeterminacy. For this structure, 2 1 deflection in y direction, rotation is there, 1 rotation and common delta x. Here only rotation, rotation, only rotation, only rotation, common displacement in x direction and rotation is there. So we are here neglecting axial deformation in y direction. So at roller 2 rotations are 1 rotation and delta x is there and 1 rotation is there. So 2 4 6 8 9 10 11 12 13, 13 dki. So here same concept, delta x is common for here, we are counting it over here. So 2 1 1 1 rotation, 1 rotation, rotation plus delta x, 1 rotation, 1 rotation, so 4 6 degree of kinematic indeterminacy. At hinge, okay, 1 rotation, 1 rotation, that is 2 rotations for 2 members. As there are 2 members, rotations will be 2, and here common delta x, so 3, and here only we are measuring rotation, here only we are measuring rotation, here only we are measuring rotation. So 6 dki is 6. Here if we neglect the axial deformation in y direction, so delta x and rotation, delta x and rotation, only 1 rotation. Here delta x and rotation, only 1 rotation, only 1 rotation, only 1 rotation. Guided support, 1 deflection, okay, 1 deflection in x direction, x direction. So here delta x and rotation, here only rotation. So that's why 2 2 4 6 7 8 9 10 11 12 13 14, 14 dki is 14. So here again same, delta x common over here, rotation, rotation, so 3. Okay, here common delta x and rotation. Here we are neglecting axial deformation in y direction, that's why 2 rotations, okay, 2 rotations for this half and this half, and delta y, that's why 3 number of degree of freedom is there. 1 guided support, that's why it is having vertical displacement, but we are neglecting axial deformation in y direction, that's why we are not going to consider this. So one rotation, two rotation and one deflection, one delta x and rotation, delta x and rotation, and one rotation. So 2 2 4 7 8 9 10 10 dki will be 10. Here again the same concept, common delta x over here, and two members having two rotations, 3 degree of freedom. Here only rotation, here only rotation, so phi is the dki. Here common delta x, one rotation, here common delta x and rotation, common delta x and rotation, for roller delta x and rotation, here rotation 11. Here common delta x, rotation, common delta x, rotation, here rotation, so 10. Here rotation and delta x, delta x, total dki is 4. Thank you very much.